So hello and welcome guys. Hope you are all well and safe. So we are here with another lecture. So today we are going to talk about basic concepts of prepositional logic, which is a topic of subject discrete mathematics. Okay, we are going to learn about this particular topic in Python language. Okay, I'm using Pycharm as an IDE. You can use whichever you want. So, if I tell you the definition of propositional logic, so the definition is the rules of mathematical logic specify methods of reasoning mathematical statements, and propositional logic is concerned with statements to which the truth values true and false can be assigned. That is, if we um, give any particular logic to any question or any mathematical statement, there is a possibility that it will be true or there is a possibility that it will be false. So that is the main logic on which this phenomena stands. Okay. So what I'm going to do is I'm going to give you a walkthrough of what are we going to study in this lecture today. I'm going to make you learn about this header file logic. We will make some proportional variables here, and I'll make some formula out of them, and I'll print some truth tables. I'll tell you about contingency, I'll tell you about tautology, I'll tell you about the contradiction, and I will tell you about this equivalent relation. Okay, so let's go ahead and create a new file here, which is a Python file. So I'll type my project. So I'll type proj Python file. Okay. So what we're going to do is we need some propositional variable. We need to make some propositional variables, and we are going to use some functions which are not present in this PyCharm IDE from the beginning. Okay. So what we're going to do is we're going to insert a header file named as logic.py. So see, I had already inserted this logic.py header file in my side packages of my PyCharm project. So if you want, if you can't find this header file or library, you can tell me in the comment section. I will drop down the link in the description. Okay. So as for now, I've already imported the library here. So let me go ahead and invoke it. So I'll type from logic, which is our header file. Okay. From logic import, as I'm going to import this. Okay. And star. So this is the initial statement which we gave. So let me go ahead and make some propositional variables. I'll name them p, comma q, comma r. These are our propositional variables, and I'll give the values in a function named vars, which is an inbuilt function. It takes list of strings as an argument, and the name of the strings, which is p and q and r, of course. Okay. So var function will create these p, q, and r propositional variables. So let me go ahead and refresh this. So if I type what is p here, it is a propositional variable. Okay, and if I type q here, it is also a propositional variable. If I type r here, it will be the same as well, like this. Okay. So one of the few things about propositional variables is we can do perform some operations on them as to find logics out of them. So let me go ahead and make a formula out of them. So I have an example in mind already. I'll name the formula as formula 1, which is equals to parenthesis p. Okay, this pipeline operator for or p or q, and this is AND operator, which I am going to use now, like this. And this is a symbol which represents not p. Okay, and it implies to q. Okay, this is the first formula which we are going to enter in our this particular project for the beginning. Okay, so if there is example in this example, and the first example, this is the formula which we just entered. Okay, so if there is a formula, then there must be a truth table if it is a logic. So yes, it is a logic, as it is made up of propositional variables which are based on logic. Okay, so let me go ahead and type the truth table of this formula 1. So I'll type formula 1 dot print. Okay, we got this syntax. Okay, let me press enter. You see, every case, in every case, particular case, it has returned true value. So there might be a chance, no, there is not a might chance, there it is the complete possibility that it is a tautology. Okay, and you can see this thing here, as it is typing here p or q, which is represented by this v symbol, or q and, okay, which is represented by this power symbol, not p, implies like this, it has changed like this to q. Okay, these are the type of things in which these are type of the cases in which we cannot enter this, these symbols and this particular syntax directly. Okay, so this is the way we communicate with the machine, and this is the way machine communicate with us, and to make us see the desired output or desired thing we want to see. Okay, so as I was talking earlier, that it has returned every value as true. So let me go ahead and check that is formula 1 a tautology or not. So is tautology underscore tautology, so tautology, and yes, it is, but it shouldn't be a contingency. So let me go ahead and check this also, is underscore contingency. Oh, it is not. So let me tell you the definition first. Okay, so tautology, a tautology is a formula in which always true, which is always true for every value. Okay, so I'll highlight this. Okay, true for every value. What is a contingency? A contingency is a case in which if truth tables contain at least one true and at least one false. Okay, but there was no false here. So in case of contingency, there must be at least one true and false in the same truth table. Okay, in the same number of truth values. Okay, which is not here. Okay, so let me go ahead and type two more formulas. Okay, I have already inserted them here. This is formula 2, P and Q implies R, and this is formula 3, P implies Q implies R. Okay, so first go ahead and we move ahead and check the truth tables of both of them. So I'll type formula 2 dot print underscore truth table. Okay, at that time I didn't refresh it, so I have refreshed it now. So I'll type formula 2, okay, print truth table. You see, this is a truth table. There is one false on the second position and all of them are true. Let me go ahead and type the formula 3 and its truth table, which is print truth table. Oh, you see something common here? This is the same result in both the truth tables. So there is a direct chance that it will be logically equivalent. So I'll tell you this sometime after we have finished this initial starting. Okay, so let me go ahead and check are these tautology or not, but I can see that it is visually seeable that these are not tautology as one case is false here, but they are contingencies. Okay, because there is one least true and one least false. Okay, so let me go ahead and check this. I will type formula 2 dot dot is tautology. Already knew that it is false, and similarly this is the case for formula 3. Let's see. Okay, this is false also. So let me go ahead and check the contingency case. Okay, contingency. Okay, this is true, and it will be the same for formula 2 as well, like this. Okay, let me go ahead and refresh this. So we have tested the tautologies and contingencies of these. So let me go ahead and tell you about another thing, which is contradiction. Okay, the contradictions means that it is impossible. Okay, sorry, impossible for both to be true, both logics, both propositional logical variables to be true, and it is known that the Pythagoras theorem holds. Oh, this is okay. This is the example. Okay, contradiction tells us that it is impossible for two variables to be true at a particular time or at the same time. Okay, so let me go ahead and tell you the example of it. So I am talking about any variable p. Okay, logical variable. So what is the value? A single variable holds logical variable that is true and false. And what does the not value of that the same holds? It is just the opposite of the first bit, which will be false and true. Okay, so if I write it like this, it will be true and false, and it will be again false and true. Okay, so you can see here that they are opposing each other at every case. This true has one fighter which is false, this false has one fighter which is true, so they cannot be true at any singular point. Okay, so if I mark this as, I'll type p and operator and third symbol and p and not p is a contradiction or not. Okay, wait, let me go ahead and refresh this. Is a contradiction or not? Okay, is contradiction or not? Okay, contradiction. Okay, it is bound to do so, so I'll type this again, no problem at all. Okay, this is true as it is a contradiction. But if I talk about p and q, which both are different variables, so they can be true at any particular instant. So if I type p and q, and if I'll check is a contradiction or not, see, this is false. That because they are two different variables, we cannot determine the values, the truth table values they can have at any particular instant. Okay, so there might be a chance they will be true, and if we will see the truth table, we can be make sure. So now I'll tell you about the logical equivalence. I told you about this. The propositions are equal or logically equivalent if they have the same truth table value. Okay, so I just told you earlier that the truth table values, okay, the truth table values of formula 2 and formula 3 are same. If you want me to show you one more time, okay, I'm going to show you again. See this and see this. You see, both the values are same. So there might be a chance that they are logically equivalent. Okay, so if I type formula 1, okay, sorry, formula 2 equals equal, which symbolizes the logical equivalence between formula 2 and formula 3. So if I press enter, okay, this is true. But if I type formula 1 and formula 3, this will be false, and yes, it is. Okay, so at last I'll perform some random examples of truth table one by one of different formulas. Okay, so these are the examples we are going to take. So I'm going to type the truth table of each of them one by one, so see clearly and carefully. So I've entered formula1 dot print truth table, formula1 dot print truth table. So I'm typing enter here. So this is the truth table of formula 1, and if I change it this to 2, this is for P or Q, and if I type this, sorry, if I type 3 here, this will print of not P, which is false and true, as P will be true and false. So let me go ahead and type 4 here. So this is the truth table of P implies Q, and if I go ahead and change 5 here, so this will be the truth table of Q implies 4. Okay, so these are our random examples. You can see them like this. Okay, so the video came to an end from this last topic, the random examples. This is my last video of this session. If you watched all of my videos, thank you so much, guys. If you haven't, then you should watch the videos. There is so much to learn there. And if you have watched this far, thanks a lot, guys. Okay, please like, comment, share as much as you can all of these lectures. If they are helpful or not, you can tell me in the comment section. I'll be available. Okay, do like this and subscribe and share and comment whatever I could do better. Okay, thank a lot, guys. Okay, this was Iron Bhatt signing off.